Hi, I'm Lainey Mays.
And I'm Chris Blagan. We're Group 19, and we're going to talk about Jacqueline Kromowski's article published by American Dairyman titled Gene Editing, A Promising Future in Dairy.
Which is about incorporating the POL gene through homology-directed repair.
Using gene editing to select for the POL allele in dairy cows is beneficial to reduce the stress caused by removing horns, and is a lot quicker than the traditional ways of selecting traits.
The traditional way of selecting for the POL gene would take many generations to complete. The study conducted by Eileen Elizabeth Wall took 16 years to complete and had 3 backcross generations. 50 Big P bulls were required and 400 cows needed to be maintained for the backcrossing phase. Step 1 would be to select a Big P bull and breed to a selected horned cow, resulting in 100% Big P offspring. Step 2 would be to mate the F1 females with a preferred breed A, resulting in 50% Big P and 50% little p. Step 3 would be to backcross the Big P animals to breed A, which would be resulting in a 50% Big P, 50% little p. Step 4 would be to repeat step 3 until desired proportion of genes you would want are achieved. Step 5, make graded up Big P offspring, resulting in 25% Big P, 50% Big P, and 25% little p. Step 6, progeny test, polled bulls mate to horned cows.
Another problem with using the traditional method to select for the POL allele is that you can get undesirable traits passed along with it. This stack of sticky notes represents a chromosome with an undesirable trait located near the POL allele, making it more likely to be passed on with it. The article talks about using a gene editing mix to insert the desired allele with in vitro fertilization. We have the single-celled zygote represented by the egg and the editing mix in the syringe. They inject the editing mix into the single-celled zygote and cause the double-stranded break and repair to introduce the allele. Using HDR, or homology direct repair, we can insert the POL allele in a specific place. Here we have the target DNA represented by the orange and purple pipe cleaners, the homologous region in pink, the desired insert, our POL allele, in silver, and the Cas9 complex represented by the scissors. This naturally occurring process can be modified to insert desired alleles, such as the POL allele. With homology direct repair, the Cas9 complex targets a specific part of the DNA to cause a double-stranded break. The POL allele can then be inserted between the homologous segments bordering the cut site. The endogenous homology direct repair mechanism uses homologous regions to rejoin cleaved DNA, and then you have your modified DNA strand. Gene editing could be used for other traits too.
Once scientists know their source codes at other levels, they can change other traits that will improve animal welfare, like heat resistance, foot rot, tuberculosis, tick-related illnesses, and tons of others. Gene editing is not only the future of improving the dairy industry, it will be the future of improving all livestock industries soon.
The first generation of gene-edited polled Holsteins have already been born successfully in 2015, and the main thing holding back its use commercially is the regulatory approval for their human consumption, and it won't be hard to garner support for its use since most breed associations are already willing to work with this technology.